Okay, we've got a couple minutes after, so I think I will get started. And this will be recorded, so we'll get you'll get an email link after the completion, and you'll be able to revisit it if you want. My name is Hugh Petersen. I'm the product manager for the DoseView 3D Water Phantom. We like to say it's your time, be precise. Obviously, the water scanning is a time-consuming endeavor, and with our system, we like to think that we hopefully kind of reduce some of the pain points and help you get your scanning done expediently and move about for your other functions and duties. Today's talk is kind of going to be it's an overview of some of the functionalities and the benefits and the features of the DoseView system. It's not really intended to be a complete in-depth over in-depth deep dive into the system. If you want to do that, I'd be happy to set up a time with you to do that kind of individually, so you can get your questions answered. You can see it in a little more depth, and I don't want to take too much of your time today anyway. So that's kind of what the plan is for today. Just a brief overview, probably 25 minutes or so, hopefully, if things go well, and we'll get you kind of on your way and on your day, or your afternoon, as the case may be. And for some reason, my PowerPoint is not moving. There we go. So, even through these times, like we're all kind of facing interesting challenges right now. You know, Cancer doesn't stop. It affects family, coworkers, friends, in any number of different ways. And the group here at Standard Imaging, we're very proud to be a leading manufacturer of test equipment and QA equipment. And we're there through this and beyond and before. So we want to partner with you in precision and hopefully be your QA company of choice. A little bit of housekeeping. Today, like I mentioned, will be recorded for further review. You'll get a link to the recording via email after the fact. If you have any questions during the presentation, please feel free to put them in the either the questions or the chat box below on the interface, and I can address those at the end. But a little bit about Standard Imaging. We've been in business since 1989. A lot of you are probably familiar with some of our products. The well chamber, obviously for brachytherapy, was one of our first products. A number of different electrometers, including the Max 4000 and the Supermax, as well as our X-rated line of ion chambers. We also design a full suite of QA products, both software and hardware, phantoms, patient QA. We have a wireless and filmless QA system for CyberKnife called the Stereo Checker. So we've got a whole host of QA products that I invite you to maybe visit our website and take a look at if you're not familiar with everything. But moving on, the DoseView 3D Water Phantom, as I mentioned, this is our 3D Water Phantom. We've been manufacturing water phantoms in many different shapes and forms since about 2000. Starting with our 1D Phantom, we make a 2D Phantom that if any of you are tomotherapy users might be familiar with, a tomo scanner. We actually produce that for Accuray. And we've also have the DoseView Water Phantom. It's about 7 or 8 years now in release. We've got users all over the world from the States to Canada to Mexico to Poland, Asia, and China, Japan, and India, as well as many other places, Russia, etc. So it's a well accepted system. It's worldwide, and we have a lot of users. So it's got a good user base out there. So water phantom objectives, obviously acceptance testing, checking your systems versus the stated specs of the manufacturer, commissioning the Linux, getting all your energies, your field sizes, your wedges, etc. For placement into the treatment planning system and comparison there. Your annual QA, for example, your TG-142 tests, and then your periodic checks of beam quality as they're needed. So the thing with the water phantom, obviously, it's not something that comes out every day like some of your other systems or other equipment. So you want something you can get back to. You want something that's highly accurate and repeatable. You want something that gives you high quality raw measurements. You don't want to have to do a lot of post-scan processing with the data, and that's one thing with our manufacturing process and our software. It's very, very robust in that sense. You want a reliable hardware that in operation year after year. You want something that's easy to use and set up, since you're both the reliable operation, but also the ease of setup. You're only using it best case scenario on an annual basis, maybe a couple other times a year. So you wanted something that you can go to and be familiar with and not have to relearn everything. And that's one thing we've made great strides in our software to make it just that, to be able to go back to and revisit and not have to relearn everything. It's a very intuitive interface. And of course, you want that flexibility and compatibility for a variety of detectors, from ion chambers to diodes to maybe our scintillation detector for a small field. You want a variety of protocols to be able to do your calculations or your treatment planning formats for treatment planning entering. We do a number of different ones as well, and that's all included. There's no additional costs for different treatment planning systems. So we cover a whole host of different ones, from Varian to the Eclipse to Monaco, Research, et cetera, and other ones as well. So we have that flexibility as well. So what gives us some good, accurate, and consistent positioning in our system? We use a heavy gauge aluminum frame. It's extruded aluminum, so it maximizes rigidity, it simplifies the setup, and it maintains that reproducibility. All the positional accuracies are within 0.1 millimeter per axis of the system in the X, Y, and Z directions. So you can always be assured that you're getting very repeatable, very accurate measurements. It allows for a very quick 3-point leveling, and I'll get into that in a little bit, discussing the capabilities and the functionality of our leveling and alignment system. And even before the systems go out the door, they're tested on an industrial coordinate system that both verifies their accuracy, and they're also run through a burn-in test to assure that all the motors and everything else is in sync and calibrated correctly. So we have that functionality, and so you can rest assured when the system goes out the door, it's going to be full functionality for you. A few points just for design for ease of use. The water tank and frame are mechanically secured for long-term accuracy and integrity. We use a advanced suction drain to minimize the amount of water in the tank after it's drained. It has a little moat around the edge of the tank, so even if there is a little residual water, it will sit below the scanning mechanism, so the scanning arms are not sitting in the water for any length of time. So it keeps any kind of mineralization or oxidation or anything like that. There's varying degrees of water quality out there, so we do recommend using distilled water. But if that's not an option, you can rest assured that when you drain the tank, the armatures will not be sitting in a pool of water. And we've got a fully integrated lift and reservoir cart with a precise positioning platform. If you don't want the reservoir, we also have an optional lift cart as well. A little bit more about the positioning platform. It's got a course adjustment at 45 and 90 degree angles, and one of the legacy things out there, if anybody is still using on Sentra, it also has the 10-degree detents to be able to rotate at every 10 degrees as well. But if you're doing your diagonal scans, you can lock it in at 45 and 90 and very easily set up for those diagonals. And then you'll also see on the edges a couple of black knobs. Those are your fine adjustment positions. We do a fine adjustment in the X and the Y, and also rotational. So once you get that course adjustment set up, you can then fine tune the position of that tank to get it centered under the crosshair with the lines and marks that are on the tank itself. We just released last year our new Generation 2 hardware with a different extruded aluminum frame, as I had mentioned, that improves rigidity. It's a little more compact design. It's now has a lower profile, so it is Halcyon compatible. It will fit in the Halcyon bore, and you can utilize it for Halcyon checks as well as your conventional C-arm Linacs, and still maintain the full scan diameters or dimensions that you need for your for commissioning and measurements. We have wireless connectivity. We have an intuitive wireless pendant, as you can see here. It has a built-in display, kind of just showing you where your X, Y, and Z positions are at any time. It simplifies your setup and system configuration, so you can easily walk around the Phantom while you're doing your leveling and runouts with your chambers to make sure that everything is aligned correctly. Again, the onboard display shows you the constant probe position. 3 touch button speeds, including a 0.1 millimeter step, and then a slow and a fast speed as well. So you can, with the fast speed, obviously you can get to points of measurement quicker, and then you can fine tune that with the slow speed and the step. Nice thing too, it also has an initialize button on the pendant. So when you turn the Phantom on, it'll automatically initialize, but you can initialize it from the pendant as well. And another nice feature, it has a bias switch on the pendant. Many physicists have told me that as they walk in the room to change a chamber out or do something within the water fan and leave the bias on, have to wander back out to the console, turn the bias off, and then back into the room. We have a disable bias button right on the pendant, and people really like that as well. And another nice feature is you can utilize the whole system in either a wired or a wireless connectivity to the PC. The system comes with a Zigbee, an XBee radio system, very similar to Bluetooth, but it's more robust, has a little more range. And you can set that up, have a receiver in the room on the wall, and then the motion control unit itself has the other component, the transmitter, so you can do wireless connectivity if you want. You can also use it wired with included cables. We have the cabling that is included with the system as well if you are more comfortable using it in a wired configuration. So that's included as well. Gives you that versatility and convenience. Experience in electrometers. Like I said, we've been building electrometers for the last 30 years or so, and we've become very adept at it. And with the electrometer for the DoseView 3D is no different. It's a charge digitizing electrometer for very high speed acquisition. Has a very fine 10 femtocoulomb resolution. You have your dual polarity bias voltages, so you can either do positive or negative bias voltage, and you also have independent bias too. So if you're using, say, a spherical chamber or a larger volume chamber for your reference chamber, you can turn that bias up to make sure that you don't get any issues with like recombination or anything like that. So those are independent as well. And as I mentioned, we've got some time-saving features for setting the system up. We have a versatile detector alignment system, as you can see here in this image here. Hopefully you can see my mouse, but with the orange arrow is showing you the alignment jig there, and you can see it down at the bottom on the left of the array of chamber holders. It's a very simple system. We don't, we've kind of thought about it, as far as some of the systems out there using automatic leveling and things like that. And honestly, we've kind of looked into that and we played around with it. But the tried and true method of a 3-point leveling system with combination of our water surface alignment jig gives you kind of a much better, a much more improved view of what's going on. You don't have to rely on electronics, and you don't have to, if you can do some fine adjustment, you don't have to run through the whole process again. If something does not quite line up correctly, you can do some quick adjustments there. And with our alignment jig, as you can see, has crosshairs and an X on it that gives you the ability to set that at the water level. And as you do your runouts, you can look for any distortions. And it's a very easy, if there are distortions or leveling issues, you can quickly adjust them with our leveling screws on the system. And then the nice thing too, once you have that leveled, you take the chamber alignment jig, which is the image in the upper right. You place your chamber holder right on that jig, put the chamber in the system, align that line on there to the line on the buildup cap for the ion chamber. And then when you take that holder off, replace that right on the chamber carriage in the scanning system, and it puts that effective point of measurement of the chamber right where it should be. So you don't have to kind of play around with that either. Once it's set up out of the water, you move that into the carriage on the robot, and you're right in line where you need to be. And you can also see there's also a number of detector holders included for any number of parallel plate chambers, from the Marcus chamber to the Roost chambers, Farmer chambers, our scanning chambers, small volume micro chambers as well, and also some there's a universal one as well, so you can kind of fit other kind of non-standard chambers in, including diodes, and they can be aligned in either a horizontal configuration, or if you're using a vertically based diode, you can set them vertically in the holder as well. And I kind of talked about the water leveling alignment jig. We have an automatic find the beam center setting on the software. Basically, once you get the chamber lined up, you just turn the beam on, hit the automatic beam center. It'll run out to the 50% lines in the X and Y direction and give you those correct shifts to get that chamber centered in the beam. Very quick and easy. And it also includes our 3D system includes our X-ray and A28 scanning chambers. They're our standard 0.125 cc volume scanning chambers. They have a perfectly spherical collecting volume. So if you're going cross-plane or in-plane, you don't have to worry about any kind of offset or anything like that. You get good readings in both directions without any kind of funkiness with your reading. All our chambers are homogeneous Shanka plastic, including the collector garden shell. So it's a conductive plastic, and there's no high Z material in the effective area of the chamber. No metal detectors. There's no graphite coatings to slough off and flake off within the chamber. So they're very robust chambers. And we have an excellent warranty because of that. Because they're proven quality, we can offer a 5-year chamber warranty on those as well. And the nice thing about our chambers too is they are repairable. For some reason, if one gets dropped, or whatever happens with it, if you crack a shell, things like that, they are repairable for a fraction of the cost of a new chamber, which is pretty unique to the X-ray line of chambers as well. And then we have, like I said, an offering of many different detectors, our ion chambers, our diodes, and then our W1 and W2 scintillators as well, which are a 1 millimeter by 1 millimeter or 1 millimeter by 3 millimeter detector. So very small resolution for small field measurements. And the software now, kind of jump into this a little bit. Like I said, we want to make it easy, and we want to make it something that you're familiar with and jump back into without having to relearn the whole thing. So we maintain that easy left to right, top to bottom navigation, like you're kind of used to with any kind of Windows environment. We have no hidden features. Everything is out in the open, and you don't have to dig for things, which is nice. Very intuitive menus for scan, queue setup, for measurement and analysis. All the tools are there for you to do just that. So now I'm going to jump into the software and just kind of give you a quick overview of that. So you'll see it's a little different. We're actually, the new version of the software we're about to release probably in the next couple of months actually integrates our 1D software as well as our 3D software. But for this demo, it's just our 3D software. And basically, you set up your clinics and your machines. For example, here I've got my SI clinic, and then I've got my TrueBeam one on here. And if I open that up a little bit, you'll see you also set up your different energies and your Dmaxes for your different energies. And this is new in the new software because one thing we added for depth measurements is a forced point at Dmax. So if you're doing your depth measurements and you want to take an actual a specific measurement at the Dmax point, you can do so. Even if your scan resolution that you set may skip that. So if you're doing every 2 centimeter or 2 millimeters, and you go from 1.4 to 1.6, and you'd miss that 1.5, you can force that Dmax point to be measured as well, and then it would return to the original scan path. You set up your detectors accordingly, so your different ion chambers. You can also set in your effective point of measurement as well. So if you have to do any drop downs for your measurements, it'll automatically calculate those. You set up your scan queues, which I'll get into in a second. But also then there's preferences too. So you have the ability if you're not in the states where we typically use a comma and a period for our CSV delimiters or our decimal separators, you can set those accordingly, as well as your time and your date format. But setting up scan queues, very simple, very easy. You can add a new one. And basically you can see here where it says not set, all in gray. As you step through, and I put in my information here. This one I want MV, I want MLCs, no wedges, so there won't be anything there. But you'll see that changes to blue. Then I can click on the energies, pick out my energy I want. In this case, I just want to do 6 MV. I want to do my field sizes. Say I want to do 10, and I want to do 20, and I want to do 30 by 30. And then I want to choose my scan types. I can choose my in plane, my cross plane, and my depth. I won't do any diagonals for this one. I want to choose my depth. I want to do it. Let's do one at Dmax, and let's do one at 10 and 20. And you'll see here as I go through that, I don't want any CAX offsets, so I'll leave that at 0. And you can actually add those as you want if you want, a 5 centimeter offset or something like that. So. And then you'll see here now I've set up, there's 21 total scans for that scan queue that I just set up. Go into scan mode. I don't necessarily have to do anything here, but it's nice to have some functionality in here that allows you to do different things. I can either choose step or continuous. And you'll see my step resolution is set in millimeters. If I switch to continuous, that will switch to millimeters per second. I can also do zones. I can do single zone where all across the whole field is a single resolution, single speed of the 15 millimeters per second in this case. Or I can do multiple zones if I want a little higher resolution in the shoulder and the penumbra region. I can do that, and that is set up as 15 in the green and the blue areas, and 5 millimeters per second in the orange regions here. So you have that functionality as well. So now that all these are complete, I can save that. You'll see it saved there, and then I can go into the measure page. And here I have to configure my hardware. Very easy to do. I choose my machine. I choose my dose rates, which are set up, as defaults, but you can change those very easily. I want to choose my water phantom. In this case, I've got a demo 3D system, so I want to connect that, and then I want to initialize. Choose my detectors. I've got my A28, my first one and my second one, so those are all set. But you can go in and choose your whatever detectors you want. You can also, for some reason, if you say a cobalt system, you don't want to use a reference detector, you don't necessarily have to. Obviously in this case, because we're on true beam, we will want a reference. I go to my electrometer, I can set my bias. I want to go 350. I want to apply that both to my field and to my reference. I zero my electrometer. I set my position. This is where I would do that locate beam center, and it would run through the locate beam center as I described before. And then lastly is your phantom orientation. And your phantom orientation, basically that just shows you where the motion control unit is. So if it's coming from the side, I can rotate that accordingly, and that just kind of sets your X and Y axis correctly. So that's all set. Then I can go to my Q. I want to normalize, and I want to normalize at my Dmax depth. Click normalize. Close that. I want to zero my electrometer. I load my Q. I load my test scan. And check to make sure your dose rate settings are correct. And I start my scan. And you'll see as I'm scanning, you'll see here that you'll have a progress bar in green showing you what scan you're on and where you're at. And I did not normalize correctly, so it's giving me a kind of a wonky reading here. But you'll see as I do my measurements now, I'm doing my my cross plane, etc. So while that's going, I can kind of jump to the analyze page. Can load a couple scans so you can kind of see what we're looking at here. I'll grab a couple that I've done in the past. Actually, let me go. Grab some MV scans so we're consistent with what we're showing as far as the demo goes. And I'll grab one depth measurement as well. So I bring those scans up. You can see them here. You can either see all of them on a single page. You can view your depth scan, or you can view your profiles as well. We have all the functionalities here, a number of different filters. We have a couple of smoothing filters, a boxcar and a Gaussian. We have tooltips, of course. We have the point edit, so you can edit individual points. Normalize to value. Normalize at center. Normalize, or I'm sorry, just center. You can do your average asymmetric. You can do your mirroring plus to or minus to plus. You can mirror plus to minus. You have the ability here to flip the scan, and then also your shift. So if I were to apply any of these, you always have the ability to remove the last filter. If you see anything here, like I can do a shift, and I'll shift it like I'll shift it 1 centimeter. You'll always see that it will. You can show the raw data always. So there's your raw data. This is your filtered data with showing you that shift. If for some reason I kind of think about it, I'm like, well, why did I shift it? You can remove that filter very easily, and you'll get back to your raw data very, very quickly, very easily. In the depth measurements, we have the ability to convert to dose. So instead of getting an ion reading as you see here, you might have heard that ding. That's just telling you that it's time that one of your scan parameters is done, and it's telling you that now you need to change your field size. So it's got that indicator both of completion, but also if something needs addressing. But also, as I had mentioned, it shows you your chamber diameter here that you entered in your normal chamber setup on the setup tab. And that also gives you the ability to do your automatic chamber drop for doing your dose conversion. So now you'll see down here as I change that, it tells me that I've actually converted that to dose from just an ion measurement. So we have full export capabilities. We export, like I had mentioned, to any host of systems, including the Eclipse, Monaco, Electro Aqua QA. We're Aqua compatible with the DoseView system, Philips Pinnacle, RaySearch RayPlan. You can save them as DoseView files if you want to transfer them to another PC and import those. CSV, obviously, you can do PDDs, and then you can also do calculated TPRs as well. So you have all those export functionalities that are very easy to utilize. And there we go. My GoToMeeting dashboard is in the way of everything, so sorry about that. Metrics are all there as well, so if you want to check your Dmax at certain depths, things like that, your profile metrics as well, your symmetry, your flatness, the penumbra width, etc. Those are all easily available. Also, we have a number of different protocols that you can utilize: APM, IEC, the Electa USA, Varians, the Indian ARB, and also, of course, FFF is capable as well. So that's kind of one thing I didn't mention too is import. You can import data from legacy systems. So if you have an older system, a PTW or an IBA system, you can import those scans for comparison or analysis as well. Reporting report generation at this point is in CSV format and an Excel spreadsheet type situation. In the near future, we will be exporting to PDF also. That's going to be in a future release. But that's kind of just like I said, a quick overview of the software. As you can see, it's very, very easy, very straightforward. Gives you the tools you need for your system measurements and importation into the treatment planning system for your commissioning and your annuals and your acceptance testing. So it gives you all the functionality. And like I said, this is just a very quick overview. So if it's something you're interested in seeing a little deeper dive on, feel free to jump on either sales@standardimaging.com, and your regional representative will get in touch with you to set something up. You can go on our website. We've got a number of different videos and things like that, different resources you can utilize there to take a look at it. But you can also, there's a find your regional rep or your distributor assistant at our website also to give you the ability to kind of check in with us and see if you want to do that deeper dive. But let me jump back to my PowerPoint, and just wanted to kind of touch a few summary points here. Again, the design and manufacture our system gives you unparalleled repeatability and accuracy. Your positional precision is all within 0.1 millimeter accuracy. It's a quick system setup with our leveling system and alignment jig. Wireless functionality for easy setup and time savings. Fast acquisition dual channel electrometer with the independent bias, and a very intuitive and versatile detector alignment system, as I had mentioned too. Software-wise, easy left to right, top to bottom navigation. All your tools are there. Quick queue setup for with easy copy and editing functions, which I didn't mention, but you can easily go in, and if you have your energy set and you want to maybe use that same scan plan for going from 6 MV to 10 MV, you can just copy and edit those with one click, very easily done. No hidden features, everything is right out front for you. You have the ability of doing the step or continuous scanning with the multiple zone resolution. Full functionality of importing the legacy scan data, so you can import that very easily and bring those up. Export to any number of treatment planning systems. Very straightforward scan processing and metrics as well. And a couple other things. Last slide, I promise, except for my thank you slide. As I'd mentioned at the beginning of the software, we're doing an integration of our DoseView 3D and 1D software. So the 1D software, it kind of involves that a little more. There were a couple changes and improvements on the 3D side, but that integration of the 1D software really builds upon and enhances what we have for the original 1D software. And on that note, we are, if you by chance have our 1D water phantom, our DoseView 1D, and also either our Max 4000 or our Supermax Electrometer, we are looking for beta testers for the 1D software. So if that's something that interests you, or you have the equipment to do so and would like to maybe look into that, please feel free to email me, and my email is on the next slide, so you can grab that. It's hpetersen@standardimage.com. And then the next down the road, we're going to be doing some improved scan comparison capabilities, not only being able to select a reference scan set and do comparisons for future scans, but also have a gamma comparison as well. So that's something we're working on for the future, as well as the mentioned PDF reports as well. So thank you very much for your time. As I had mentioned, please feel free to visit standardimage.com. We've got a lot of resources there, including pre-recorded demos on just about any of our products. We have a webinar link that if you're interested in some of our other products, you can join those webinars as well, just like you joined this one. From anything from our Adaptivo patient-specific QA software, EPID-based software, our Linac View software, which is log file analysis, our stereo checker for CyberKnife, which I mentioned was our filmless system. So feel free to to peruse our website. And then again, if you have any further questions or like more information on the DoseView or any of our products, sales@standardimaging.com goes into our general sales and will be directed to your specific rep. Or if you have any questions for me, or if you do have interest in the possibility of being a beta tester for our 1D software, happy to talk to you about that as well. Other than that, I don't see any questions on the question board. So if you have any questions, again, please feel free to contact me after the fact. And I thank you all very, very much for your time. If there's anything Standard Vision can do for you, just let us know. Thanks very much.